Again, we have seen it before in grade 9 and in previous grades, and maybe a little bit this year. But I thought we'd review today. So Pythagorean theorem states that for a right angle triangle, the length of the hypotenuse is equal to the sum of the squares of the other two sides. So we'll look at what does that mean. So in a minute here, we'll look at that. But before we start, let's just draw a little right angle triangle down here. So remember, right angle triangle has that 90-degree angle in the bottom. We have our hypotenuse over on that longest side. We call that side C. That's our hypotenuse over there. The hypotenuse is always the longest side of the triangle. It is always across from the right angle or the 90-degree angle in the triangle. The other two side lengths in the triangle, remember we labeled those either A or B. So we could put the A at the bottom, the B over here, but it actually doesn't matter. Those two can be reversed. So we could have called this one A and called this one B. It doesn't matter. They can flip-flop. C is important. It's the hypotenuse over there. Now, this idea of the sum of the squares of the other two sides, let's just look over here for a minute at this diagram. So in the center, we have our right angle triangle. If we were to take the length of each side and extend them to make these squares. So we took that side length A and we made a square. This square over here has a certain area, A times A. Well, if I was to take that area and the area of this yellow, they are actually the exact same area as this purple square over there. Those are matching in size. So formula for this, I think most of you probably remember a squared plus b squared equals c squared. This formula we can use that way. Remember, if you want to, it's usually we say it that way, but we can also say c squared equals a squared plus b squared. It doesn't really matter. It depends on what you want to solve for. So let's look at it a couple examples. So first thing, remember, is label your sides. In this particular triangle, example A, the side's already labeled. The other two sides, we sometimes call them legs. This is, let's call that A and that B. Doesn't matter, again, which one's which. Because we're solving for our hypotenuse, our side C, I'm going to use the formula c squared equals a squared plus b squared. And then I'm going to substitute in. Instead of an A, I'm going to substitute in a value of 1. Instead of a B, I'm going to substitute in the value of 5. Then I'm going to do my squaring. Remember, when we square a number, it is multiplied by itself. 1 times 1 is 1. 5 times 5 is 25. You can also use that square button on your calculator if you need to. When we add those together, we get 26. We then have to get the value of C. We have the answer for C squared. So the opposite of squaring, square rooting. What times itself is 26? Well, it's going to be a number a little bit bigger than 5. When I type that in my calculator, I'm going to have to round the number. I'm going to put a dot above to say this is approximate. The value I get when I type it in my calculator, 5.009. Sorry, no, 5.099. So then I have to decide, do I want to round? If I want one decimal spot, the nearest tenth, I look at the number after that. In this case, it's a 9. So because it's 5 or bigger, I'm going to round up my answer here, 5.1, to the nearest tenth or the nearest one decimal spot. Let's look at our next example here. Our next example, we'll label our sides. So the longest side, the hypotenuse, is the 36. And the A and the B, it doesn't matter. I'm going to call this bottom one A and this one B. Now, because I'm, in this case, looking for this A value, I'm going to flip my formula around. I'm going to write A squared plus B squared equals C squared. And then let's sub in our values. Instead of an A, I'm going to put an X. Instead of a B, I'm going to put 24. Instead of a C, I'm going to put 36. When I square those numbers, 24 squared, 576. Again, this one I'd need to use my calculator, 24 squared, or 24 times 24, and then 36 squared, 1,296. I want to isolate or get this x squared by itself, so I'm going to subtract the 576 from both sides. On the left-hand side, what's left? Well, these 576 make 0, so what's left? X squared. And when I subtract the other two values, I get 720. And then solving for x, I need the square root of 720. This number I do have to round. I get 26.83 in my calculator. So if I want to go to the nearest decimal, I'm going to do 26.8. This one I don't have to round up because the number after the 8 was 5 or smaller. Sorry, smaller than 5. And that's all.